Module on map reading and coordinates. So, what is a map? A map is a visual representation of an area on the Earth's surface. Maps help us understand location, distance, direction, and geographic features. They are essential tools in navigation, geography, research, intelligence analysis, and open-source intelligence. Basic directions on a map. Most maps follow a standard orientation. North is at the top, east to the right, south at the bottom, and west to the left. Many maps also include a north arrow to indicate direction. Geographic coordinate system. To pinpoint a precise location on Earth, we use the geographic coordinate system. This system relies on two values, latitude and longitude. Together, these define an exact point on the planet's surface. Latitude lines run east to west and measure distance north or south of the equator. They range from 0 degrees at the equator to 90 degrees north at the North Pole and 90 degrees south at the South Pole. Latitude tells us how far north or south a location is. Longitude lines run north to south, from pole to pole, measuring distance east or west of the prime meridian. They range from 0 degrees at the prime meridian to 180 degrees east or west. Longitude shows how far east or west a location is. Example of coordinates. Coordinates are written using two numbers, latitude first, then longitude. For example, 13.7563, 100.5, 018. The first number represents latitude, the second longitude, pointing to a specific place on Earth. Coordinate formats. There are three common formats for coordinates: decimal degrees. For example, 13.7563, 100.5018, commonly used in digital maps. Degrees, minutes, seconds. For example, 13 degrees 45 minutes 23 seconds. North 100 degrees 30 feet, 06e. Expressing each value in three parts. Degrees and decimal minutes. For example, 13 degrees 45.383, n 100 degrees 30.108 feet e. Often used in navigation systems. Coordinates can also use positive and negative values. Latitude, positive for north, negative for south longitude, positive for east, negative for west. For instance, 40.7 minus 74 indicates a northern latitude and western longitude. Map grid. A map grid consists of horizontal and vertical lines drawn over a map. It divides the map into sections, helps locate places precisely, and assists with navigation. Grids are based on the geographic coordinate system. Map scale. The scale shows the relationship between distance on a map and actual distance. For example, a scale of 1 to 50,000 means that 1 centimeter on the map equals 50,000 centimeters, or 500 meters, in real life. Scales can be numeric, graphic, or verbal. Compass. How it works. A compass is a navigation tool used to determine direction. Its magnetized needle aligns with the Earth's magnetic field and points toward magnetic north. Types of north navigation may use three types of north. True north, toward the geographic North Pole magnetic north, indicated by a compass map north, toward the top of the map, bearing or azimuth. A bearing is the angle between north and a specific direction, measured from 0 degrees to 360 degrees. For example, 0 degrees is north, 90 degrees east, 180 degrees south, and 270 degrees west. Bearings allow us to describe directions precisely. Datums and the WGS-84 coordinates rely on a mathematical model of the Earth called a datum. The most common today is WGS-84, the World Geodetic System of 1984, used by GPS and modern digital maps. Different datums can cause small variations in location. UTM coordinate system. Another way to describe locations is the Universal Transverse Mercator, or UTM system. The Earth is divided into 60 zones, each 6 degrees of longitude wide. Locations are expressed as eastings and northings. UTM is widely used in military maps, engineering, and geographic analysis. Geolocation. Geolocation identifies the location of images or videos by analyzing buildings, roads, landscapes, and satellite imagery. Common tools include Google Maps and Google Earth. Summary map reading combines understanding cardinal directions, using a compass, interpreting latitude and longitude, working with map grids, measuring distances, and determining direction with bearings. Modern techniques also include datums, coordinate systems, and geolocation tools. These skills enable precise location identification, essential in navigation, analysis, and open-source intelligence.